Mishra is a senior sales engineer at SyncSoft. Today he will talk about the importance of data integration and data quality in the big data space. SyncSoft is a gold sponsor and we really appreciate your support. He will be presenting the talk titled Populating Your Enterprise Data Hub for Next Gen Analytics. Please join me in welcoming Sushree.
Thanks. All right, so we are ready to start now. Quick introduction. So my name is Sushree Mishra. I'm a senior sales engineer at SyncSoft. I've been with SyncSoft for about 4.5 years now, almost. I have about more than 10 years of experience in the data warehousing, data quality, data integration, and Hadoop space. So today I'll talk about populating your enterprise data hub for next-gen analytics. And your sources could be legacy systems, your sources could be flat files, your sources could be some databases. We'll talk about how SyncSoft and the different tool sets that we have can help you in leveraging that and getting all your data into your data lake, and then boom, you can cleanse that data and increase the quality of your data. And then once you're done with that, almost half your job with the analytics is done. The next step is just run your maps, run your models, machine learning models on those, and then come up with visualizations and some good talking points. So let's get started here. So brief agenda. I'll do a quick, very quick company overview. I'll talk about the biggest implementation challenges that you're facing these days and why SyncSoft can help you in getting rid of those challenges, if you will. We'll talk about data integration in big data. I'll talk a little bit about the real-time change data capture and how you can leverage that to get all that data that you're getting into your transactional, your data warehouses, all that data that you are getting on your legacy databases or mainframes or iSeries, how you can get all that data into a Hadoop and then run analytics on that. It's very difficult today to run your analytics on legacy data. I'll quickly run through some data quality functional examples, talk about our data quality offering, and we'll have some time for Q&A at the end of it. Sounds like a plan? Great. All right, so SyncSoft is a trusted industry leader. So if it was set up in 1968, so I can say it's the 50th year. It's one of the oldest software companies, very close to when IBM was starting with mainframes. That's where we started. We came up with the algorithm for the sorting on the mainframes. That's where we started from. But we have moved a long way from there. We have championed the idea of moving from big iron to big data. When I say big iron, it's mostly mainframes that you recognize it with. But yeah, you can talk about legacy relational databases. You can talk about hierarchical databases that were there before that. So we can help you guys get rid of all those and get all your data into Hadoop, and then run your machine learning on that. These are the 4 pillars, if you will, that we have here. That we have data infrastructure optimization. I won't talk about those today. These are some of the verticals that we have. Data availability. I'll talk a little bit about the Mimic Share product that we have, which helps in real-time CDC. We'll go deep into the data integration space, especially the DMX Edge and DMX change data capture, which is the high-performance ETL tool we have at SyncSoft. We'll definitely talk a lot about data quality. And although we have different portfolios under Trillium and data quality here, I will mostly concentrate on the Trillium quality for big data, how you can run quality, cleansing, matching of your records on a large scale in the big data Hadoop space. Before we do that, I want to talk about the biggest implementation challenges that you guys are facing today. So this was the result of a survey we did some time back, and these were the primary 7 challenges that people face today in implementing something in the big data space. The biggest one is data quality. You can get your data in just unstructured data into HDFS, or you can put it into some data warehouse table in Hive or Impala, whatever distribution you're using. But the quality of the data, like if you have a lot of nulls for a particular field that you are running analysis on, it's not really helpful to you. You cannot really trust that data that you are running analysis on. So that's the biggest challenge. There are some like skills, of course, it's a problem. Data governance, rapid change is a problem. But I will talk about the fifth, sixth, and the seventh one, which is about CDC, getting your data, which keeps on changing, because you cannot always get off your legacy systems right away, because you have a lot of applications which are tuned into it. So you want to have change data capture from your legacy system, and you should be able to do it on a real-time basis, ingest into Hadoop, and run analytics on that. So how can you do that? We'll talk about it, and how SyncSort helps you do it. We'll talk about that as well. Mainframe is a big factor, where getting data off of mainframes and ingesting into Hadoop is a big problem, because mainframe, the whole implementation that was done with mainframes, because of the complexity of the data structure, the episodic encoding, the way the complex number types you have in mainframes, it's really challenging in there. Data movement is another problem, where you are unable to move data on and off the Hadoop ecosystem as easy as you like. It's not that easy. So these are some of the challenges that we try to solve. So let's talk about data integration in big data. So our motto is design once, deploy anywhere. That's the idea we go with. So here I'll talk about the high performance ETL tool that we have, which is called DMX Edge. It's the Hadoop version, where you use a single graphical user interface to build your pipeline, and you build your ingestion job, you build your processing once you have ingested your data, and once you have built your process, you can deploy that anywhere. And when I say anywhere, you can deploy it on-premise, on cloud, wherever your server is. You can deploy it on a Hadoop cluster, and you can run it as a MapReduce, Spark, or any future platforms, if you will. You can deploy it on Windows, Linux, Unix. There are the possibilities are endless there. So why I say you design once, deploy anywhere is, from a developer's point of view, you don't have to think about, okay, I want to run a MapReduce job. What should be on my mapper side? What should be on my reducer side? You don't have to think about that. We have all packaged it together so that it's for the ease of use for development and faster development. That intelligent execution, which is part of our DMX engine, takes care of that. And I'll show you how we do that in a couple of slides. Let's talk a little bit about the integration architecture. So you have variety of sources out here. You call it mainframe to vSAM data sets, RDBMSs, you have OLTP data, you have web logs, social network data. So how do you ingest that into your Hadoop system? That's the first step, right? Once you get your data in, then you process them, and then you run analytics on that. The first step is, of course, you want to do, if CDC is available for your sources, then that is something we would absolutely recommend, and you do, is that you set up CDC, only get the change data. You don't have to refresh your data on the Hadoop side every day, which is a very expensive and time-taking process. So from an integration point of view, like I said before, we can run the same job on MapReduce or Spark. We can connect to Hive. We can connect to Impala if you are a Cloudera shop. We can connect to Kafka, read and write from Kafka as well. We have a very tight partnership with Hortonworks. They are actually the resellers of our software as a EDW optimization offering that they provide. We have a very good partnership with Cloudera as well. They actually incorporated our software into their QA process, so that every time there's a new enterprise level GA version available with Cloudera, you can blindly upgrade to a latest version, because they actually run QA and regression on their platform. So that's how closely we work with the community in Hadoop. We have a native on-cluster integration as well, so we provide parcels from Bari or Cloudera Manager, so it's really easy to install and deploy. So that's kind of the value proposition you get with using this ETL tool on Hadoop. Coming to the intelligent execution, or especially for MapReduce, the same concept goes for Spark as well, but I'll talk about and stick to MapReduce for now. So this is a small example of how a DMX job looks like. It's a pretty simple job where I am trying to aggregate data on Hadoop. My input is a huge weblog input data set, and I'm processing it, aggregating it. I want to find out which are the unique IPs it's coming from, what are the different data sets available for each and every weblog output you have there. So I'm trying to aggregate that. What you see or what you build is a single task here, which is a simple aggregation task, and you don't have to really think of what happens on the mapper side, how do you shuffle data, how do you sort data. You don't have to think any of that. So what we do as part of intelligent execution, which we call it as IX, is once you submit this job, we convert it in the background and we convert it to a mapper side and a reducer side. So mapper side aggregation, we do a mapper side aggregation, we create the mapper output, we send it to shuffle, we set the partition IDs, and then the reducer side takes over and gives you the final output. So that's kind of the ease of use, the development ease that you get when you are playing around with intelligent execution. So at runtime, there will be many copies of the mappers and reducers that will be spawning, and within those mappers, DMX engine would be processing that data set, and that's where you get the performance. So really, a lot of ETL tools claim that they do Hadoop ETL processing. All they're doing is generating code and then running that code. We don't do that. We actually run our DMX engine within the mapper JVMs and the reducer JVMs. The same goes for Spark as well. In the Spark paradigm, we create our own RDDs. We generate and run inside the executors, not actually generate a Scala or a Python code to run it. So that's where we get the performance of the DMX engine, and we leverage the parallelism of the Hadoop ecosystem. Here is a quick use case of a project that we implemented at IHG. They're a big hotel group that have about thousands of hotels and properties. Their use case and business challenge was they wanted to create analytics platform, and they were not able to do real-time data ingestion and processing and analytics on that. So what they used to do is they would get their data on a nightly basis, update it, and then run their reports. So if at any given time their business users wanted to find out, okay, how many properties do I have available that are open? Can I change the room rates so that I'll get more traction into those properties? They didn't quite have that kind of a vision into their data real time. So this is the problem that we wanted to solve with DMX Edge. What we did, the first step we did is we said that, okay, let's put all your data, because the reservation system is real time. So every time there's a reservation, a change in reservation, or there's a cancellation, every record goes into the Kafka topics. So we set up Kafka topics for every line of business, and then there are about 30 different types of Kafka messages that they were pushing into the topics. We read from those Kafka topics on a every 10 seconds we go into micro batches, read those Kafka topics available on each topic, process them, and ingest it into the ADW. Their cluster is a Hortonworks cluster, which is on a Google Cloud Platform, and they're leveraging that to write their data into Google Buckets as ORC so that they can run faster analytics on that. So that's kind of the solution that we came up with, and they're very happy with it. Today, every time you actually make a booking in IHG, they would be looking at that data real time and finding out, okay, these are the number of rooms I have available in a single property, or I'm fully full and I want to bring up my rates because I have only 2 rooms available. That kind of analytics they're running real time now. Okay, data funnel, DMX data funnel is another tool that we have here, which was primarily built from a user use case, if you will, from a customer use case. But then it grew so fast and it was accepted so fast that it's actually a full-blown product which has a browser-based UI now that you can leverage. It is, the name suggests itself is that it's a funnel. You can copy data sets from multiple databases into multiple databases. You can go from database to file on HDFS. You can put into S3 buckets. If you want to filter data, you want to transform data in between, you can do that as well. But it's all automated. So I'll talk about a use case, how it actually came up, and how we are helping customers doing that. But this is kind of a short brief of what the tool does. This is the use case with Progressive. It's one of the leading insurance companies, which actually had a problem that they came with is that they had about 500 plus tables in the mainframe DB2, Oracle, and SQL Server that they wanted to move into the Hadoop space. But so today, without data funnel, what they had to do is they had to build one task or one job per table to transform them. They could not define higher level common rules or transformations for that data set. So that was kind of the challenge. So data funnel, we could easily and quickly ingest all that database tables. All you have to do is give us the database connection strings, give us the table names, or you can just give me the schema name and I'll take all the tables within that schema and ingest it into whatever your target is. It could be Hive. For Hive, we have auto creation of tables as well that maybe those tables don't exist today, but we can create them and then ingest data into it. We can also ingest into HDFS if you don't want to use the Hive metastore. So there are different possibilities available with the data funnel tool available. And today it's offered along with the DMX Edge product, so it's kind of out there for you guys to use. Any questions so far? Anything that you guys would want to know in detail? Mm-hmm.
But I saw in the solution also you have the future Apache Spark integration. Is it already there?
Yeah, the Spark integration is already there. If you like, Spark is fairly 3 years old that it started being used in production. But yeah, so we built our product in such a way that it can adapt to any distributed programming paradigm, if you will. So it was built for MapReduce, but it was easily adaptable to Spark as well. In future, it's much more faster. In future, if you want to adapt to a new architecture like Spark 2 or there's something else, then we can easily adapt to it. So that's the idea. You don't have to change your code. Today you're running on MapReduce. The same job can be run on Spark. All you have to do is just change a run parameter, and it would start submitting Spark jobs.
Because in MapReduce you can use Java or Scala, right? Scala you can.
Scala is Spark, yeah,
Spark,
yeah.
So
We are not code generators, like I mentioned before. So we don't generate code. That's why we are not dependent into what kind of programming model you're using. We are dependent into how you are distributing data and how Spark. The way Spark is faster is because it's using RDDs and reusing RDDs in memory. So we use that programming model, but the idea is the same. Is that when those RDDs are being processed, you actually have the executors, the Spark executors, which are actually processing the data. We run the DMX engine within that executor, and that's how you get the performance, and you're able to distribute as well. So
it's still on progress. It's not ready.
the Spark is ready. It's all available.
Oh, okay.
Yeah, we are talking about some future. If there's something else in future which is a different architecture than Spark or MapReduce, we can easily adapt to that. You don't have to change your code for that. I'll talk a little bit. I'll quickly skim through this. I'll now go into the details of the architecture here. So mainframe live CVDC is basically if you have a mainframe and you have vSAM data sets lying there which are changing every day. vSAM data sets are basically transactional files on mainframe. Or if you have a DB2 on ZOS, we have a solution which can look at the journal logs on DB2, look at the logs for vSAM, and push that data set into Hadoop or open system side. So that's it's heavily used by a lot of our customers, especially in the financial banks and insurance companies, where they want to run analytics. Also, they're kind of building a data warehouse on Hadoop. So that's kind of the two use cases we see is that instead of getting that vSAM data set, stopping the transaction on a data set and moving that entire data set, which could be sometimes 20, 30, 40 GB of data, we only get daily changes and in real time and then push it into Hive or Impala. So that's one of the solutions we have there. Mimic share, I promised you guys that I'll talk a little bit about data availability and replication software. This is a software that we acquired as part of a acquisition recently. Well, I say recently, it's about 1 year now. So CDC captures the database changes, and I'll show you which are the databases we support today. But it's a database to database replication. We are also using or leveraging this technology to do database to Kafka, database to Hive. We are integrating it as we speak. So, but today, as it is in this form, Mimikshare can replicate data from a database to another database, capture changes, and it can be multiple ways as well. These are some of the environments we support, and these are some of the leading databases that we support. The ones with the star are basically supported for target only, and it's primarily because these databases don't have a logging mechanism inbuilt into it to do that. We can, of course, set up a trigger-based CDC, but that would impact the performance of a database, which a lot of clients don't want to. But yeah, if you have some of these databases that you want to replicate into Hadoop or into some other database, we can absolutely do that. These are some of the flexible replication options, and it's really popular with a lot of our clients. A lot of our clients are using distribute method to distribute their changes on your transactional database into multiple data warehouses. So they have different groups who want running different queries on their data warehouses. So instead of writing one pipeline for every data warehouse, what they are really doing is setting up a mimic share model to copy every time there's a change in your source. That record is pushed to multiple data warehouses, and that's how you get copy. You get it also used as a backup system, and yeah, that's how it's used. You have Consolidate as well. You have bidirectional, where both the databases are transactional, so any change here will be pushed to the other way, and any changes on your target system will be pushed to the source as well, so that they are in sync. Applying changes to Hive and Impala target tables. So you guys know, if today I know asset transaction based tables are coming up, but it's still not in production yet. But we have found a way to apply the changes on Hive and Impala. You can update and delete records, and we have been able to do that by using some smart algorithms in the background. We are running some Hive queries in the background. When you submit a job, for you it's still the same task that you built. Your sources can be a file or a database, your target is Hive, and you say go ahead and apply CDC on the Hive table, and we'll do the rest. All you have to give us is any particular record should have this kind of information, should have, or whether this record is an insert, update, or a delete. That's all you need to tell us. You have to tell us what's the sequence for a particular key. If you have multiple records, you need to tell us what is the sequence of those updates that happened. As long as you have a field like update timestamp or a sequence number, we can use that and leverage that to make your changes on Hive side. So that was all about the data quality or data integration on the big data space. I'll jump to data quality on big data. Before that, any questions? Cool. So data quality usually is an afterthought in a lot of projects, because you ingest your data, you think, okay, I'm good with the data, I'll run analytics, and suddenly you find out that, okay, I'm not getting the desired results that I was looking for because the quality of my data is not good. I have a lot of nulls in a particular column, but it doesn't really handle that. So although my record count is 2 million, I'm only getting analysis on 1 million records. So these are some of the challenges that you face all the time. And how do you solve that? You use data quality product on big data. So quickly walk you guys through the portfolio that we have under Trillium. We have different portfolios of products there. So Trillium Discovery is a product which is a profiling tool. You can look at data, you can quality issues, you can find out your quality issues and then solve them before you ingest into your final target. So that should be the first step of your quality process. Trillium Quality is where you actually fix those quality issues. So if you have address cleansing, if you have matching records that you want to match and create a golden record, and I'll talk about that in a couple of slides, how the matching really works and how it's the idea behind matching. But yeah, that's primarily why it's one of the most powerful tools that uh, customers that they've told us from a matching perspective. We use so many different fuzzy algorithms to match records that it's kind of very foolproof when you get a match record. And you can configure that as well. You can customize it as you please. Global Locator is a tool which does geocoding and lat long, gives you lat long information as long, and also does address cleansing for your data. So if you can use it in a batch process, we have SaaS offering for that as well. You can use RESTful APIs to just send us an address and we'll send you a cleansed data for that. So there are different options that you can use. We have plugins for dynamic CRM, SAP ERP, MDM solutions for SAP, for Oracle and Siebel as well. So these are heavily used where if you have a CRM system or ERP system where you want your users are entering data and the quality of the data is not good. So one of the biggest problems that we see at our customer locations is that they have duplicate data in their CRM system. So if they want to search for, okay, I want to find out what's the contact detail for Sushree Mishra, and they find 5 different entries for my name under accounts or under leads and contacts, then that's a problem. So we try to solve that problem. Using our fuzzy logic and algorithm, we go through the entire data set. That's a one-time batch processing you'll do, but ongoing, using these plugins, every time someone is entering data into the CRM or ERP system, they actually real-time get a pop-up saying that this is a duplicate. Do you want to update it? Do you want to merge these records together? How do you want to handle it? So it's real-time that you get data quality problem solved. Talking a little bit about data quality process and how it fits into the data quality big data process is the first step, like I said, is data profiling. How are we doing with time? Good? Thanks. Go. So data quality process is first data profiling. You want to profile your data. You want to run some business rules and create business data quality assessment on your data. And it might be a sample set. You don't have to do profiling of your entire data set because it's not physically possible to do that. But when you take your sample sets, do profiling, you understand your data, you create your business rules, you can set up your business rules to run every day so that you can set thresholds. Okay, phone number is a field that I'm really interested in. It should not be null, or if 90% of the records do not have nulls, I'm okay with that. You can set thresholds like that, and then every day you get new data sets, we run through those, and if the threshold doesn't match, we send you alerts, we send it back to data stewards to correct them. So these are some of the steps you can do. Once you get through that process, okay, the data is good, the next step is how do I improve the quality of my data? So that's where data quality processing comes into picture. You can do validation, you can do standardization, you can do address parsing, cleansing, and then you use that information to do your matching. Data enrichment and again, verification is the next step where you talk about once, okay, I'm done with my processing, I got some matches, is that match good? For every record, you get some match scores, and based on, you can again set thresholds saying that, okay, my matching is good based if the match score for a particular record is 90%. If it's not a good match. Then you can go back and churn it out, or you can decide how to change your rules for matching. That's kind of an implementation that a lot of our customers are doing today. That actually enables you to get your customer 360 view of your entire data set. Okay, so how do you run big data process of data quality on your Hadoop system? So it's the same idea that we have with Trillium as well. Trillium is the data quality product that we have here. That's the name. You use the same UI. You build it the same way. The same idea is develop once, deploy anywhere. So once you have developed your job, you can decide whether you want to deploy it as a batch process, whether you want to deploy it on cloud or on premise, whether you want to deploy it as a real-time process, and you will have an API generated for that process. So every time you send a record, it will do a real-time address cleansing, different kinds of data cleansing, parsing, and matching as well at the same time. So this is the real-time technology is what we use to we leverage that to create that connector for CRM and ERP systems. When you deploy it to big data, you can run it as, again, MapReduce or Spark. These are two options that you get today. Of course, there's future other platforms that you can run with. But today we do support that once you have the big data process, you deploy it to big data on the Hadoop system. We are certified on Cloudera and Hortonworks with this TQBD, which is called Trillium Quality for Big Data Software. So yeah, it should. We do have Ambari packages and Cloudera parcels for those. So there's the deployment is pretty straightforward, and the runtime or the execution architecture looks something like this. So once you use Control Center, which is basically our UI tool, you use that to build your process. Once you are happy with your process, you're matching, cleansing jobs, you deploy that to your edge node of your cluster. When you're submitting that job on the edge node, you have a choice. You can decide whether you want to run it as a MapReduce job or a Spark job. Once you decide that, based on that, we distribute the processing through the data nodes. If it's MapReduce, then we spun up mappers and reducers and run inside the JVMs of those mappers. If it's Spark, then we churn up RDDs, we create executors, and then run within them. So here is an example of what the real problem behind data cleansing and matching is. So this is the biggest use case that our clients use us for, is they have sales contacts. There's one source there. There is a service contact, which is another team which has their own data set. They have a marketing lead team. Marketing team has their own lead. So they have their own source. It's kind of the same person, but how do you know if it's the same person? They want to create. So if you want to create a single golden contact record, how do you do that? That's what Trillium does. It creates you a golden record based on different fuzzy logic algorithms that we have. It utilizes that to put them together, put the data together. You can decide which field from which source you want to pick and choose to create that golden record. Which one do you really trust? Like you say, okay, the sales contact, the phone number must be good. The email from a service contact must be good. So that's how you go with the trust value. But of course, if you have all these three data sets for this example, and you are able to create a golden record, no one has to go back to their own data sets. They can use this central repository, if you will, to access any kind of contact information. So that's one of the examples of Customer 360 that we implement at our customers. I'll just talk about a couple of use cases here. One of the use cases is Customer 360. So how do you do that? You have your internal data or third party or global data that you want to put them together. You want to create a golden record out of it and then use that as a Customer 360. How do you trust that data? You bring in everything from a customer into data lake. You put everything into Hadoop data lake, and then you run through advanced data quality processes, the Trillium quality job, to churn that data and come up with one single record, or based on your matching, you get that one golden record that you can use for your Customer 360. So it basically sees that when I say 360, it's the idea that everybody in the organization is using one single reference data to get to the customers. Advanced analytics is another thing that we are heavily used for, is get that data from the mainframes, get that data from relational databases, hierarchical databases like IMS, DB2 on mainframes, or Oracle, or Teradata for that matter. Get that data and ingest it into HDFS or Hive using data funnel or using the integration tool, and then you can use the MapReduce or Spark paradigm to actually churn through that data and aggregate it, sort it, transform. You can join multiple data sets together. So the biggest advantage I find, and a lot of customers tell me, is that we have a lot of developers who don't really know Hadoop. They don't know how to code MapReduce. If you had to write like 300 lines of code, someone has to go through that and then write that code. Here there's no code generation, there's no code writing. All you have to do is use the UI, build your job like you would in a single server, and when you're ready to run that job, all you have to say is whether you want to run it as Spark. utilize the power of Spark or you want to utilize the power of MapReduce. There are different use cases which are, some are good for MapReduce, some are good for Spark. Based on that, you can utilize that and then you get your output. So that's really the biggest advantage you get here. So that's all from me. Questions? Yeah.
For the analytics and machine learning,
Mm-hmm.
like as you mentioned, the APIs or the UI that you use,
Mm-hmm.
is it not much easier if you use the Spark and the Spark sys and the machine learning library?
Mm-hmm.
The Pythons the PySpark or
Right.
Spark
Yeah.
that you use. I found it much easier than any other platform.
Yeah,
I'm
that's
not sure what kind of approach you have on this.
right. So it's good when you're trying to do some basic level ETL or transforming some data sets, some fields. What we have found is that when you're trying to do that heavy lifting ETL, like you have a data set, you transform it and join it with 3 more data sets. Again, the next step is you sort them and dedupe data records from your data set and then do something else, transform it, change data types. Once you start doing all that on a field level and you start doing that using PySpark or Scala APIs, it is a lot of code, which is time consuming. Hence, against that, if you do it in a UI, we have pre-built functions available. All you have to do is just click and drag and drop those fields and change the formats, change the data type, and everything else is taken care by us. When you are coding it, you have to know, okay, this is the RDD I need to persist into disk. This is the RDD I want to put into memory. How do I handle that? So yeah. Cool. All right. Thanks, guys. Thank you.